Good morning, guys. Hope all of you are well and pretty good. Myself, Ishfaq Suldar. I have done my masters from Kashmir University, and before that, I was in Delhi University where I did honors in mathematics. Today, I am going to make a lecture on a chapter that is polynomial. This is one of the easiest and has a lot of applications in higher mathematics. Before you people understand the concept, the definition of polynomial, I will introduce some basic terms that will make your path easy in understanding the concept of polynomial. Okay, first term is variable. I will give you an example so that you people will relate that example with this definition and you can understand by that. Okay. Suppose you are driving a car, the speed of car does not remain the same throughout your journey. Okay. Sometimes it will go up to 30, 40, 50 and sometimes it will go below that 30, 15. Okay. What is happening? Actually, the speed of car does not remain the same throughout the journey. It changes with the time. All those things that changes with the time, we call them variables. Okay, we call them variables. Actually, this word variable is derived from the word vary, and vary means change. So actually, variables are those that changes with that time, and variables we denote variables by some alphabetic numbers like A, B, C, X, Y, Z, up to so on. So variables are denoted by the small alphabetic letters like A, B, C, X, Y, Z. Okay. Now the second term is constant. Actually, the constant is nothing just the opposite of variable. If variables changes with the time, then constant remains fixed. Okay. Suppose you have 100 rupees in your pocket, it will remain same as it is. After 10 years, after 2 months, it will remain same. Okay. Constant, they remain fixed. Okay. Now the next term is thing is term. What is called a term? All these things will be used in polynomial. Okay. Actually, this term is either a variable or a constant, or we can say product of constant with variable. But you have to write down one thing. This term cannot be equal to 0. It is always non-zero. Okay, you can't take a term equal to 0. Say like what I told you, a term is either a variable. I can take a variable x. This is also a term, or it may be a constant like 3. I can take the product of a constant with variables, say like 3x. This is also a term. This is also a term. This is also a term. If I am taking 0, therefore I can't say this is a term. Actually, that term cannot be equal to 0. It is always non-zero. Okay. Now, a term is also a part of an algebraic expression. What is an algebraic expression? Algebraic expression is the collection of these terms. But here, in algebraic expression, these terms are combined with some operations like addition and subtraction. Say like I am taking terms like 3x square. This is also a term because this is a product of variable and constant, and I am taking as some constant 3. This is also a term, this is also a term. Then what I told you that what is an algebraic expression? Algebraic expression is the collection of terms, but in algebraic expression we are we are combining with some operation like addition and subtraction. I will make here operation like addition. So this whole makes an algebraic expression. Algebraic expression. This whole makes an algebraic example. I will give an more examples so that you will get the idea. Okay. Listen. I will take another example like 3x cube. I will take first terms. Okay, 3x cube is a term also. 3x square is also a term, and 4 is a term. These are the terms. Individually, they are, these things are the terms. But in algebraic expressions, we are combining with some operation like addition and subtraction. I will make use of here subtraction, and I will make here use of addition. The whole thing is here makes an algebraic expression. This is an algebraic expression. Okay, listen one. Look one thing. This is a thing that is above on the variable x. Here 1 is above on x. Here there is no variable, but you can write as x power 0 because anything raised to power 0 is equal to 1. The thing that is above on x is actually the power. We call this as a power. Here 2 is the power on x. Here 1 is the power. Here 0 is the power. Okay, but you have to note down one thing in algebraic expression. These powers must belong to the rational. It should not be an irrational number. If some x has the power in the form of irrational number, then it will not remain an algebraic expression. Say like 3x5 plus 3x 1 by 2 plus 3. It is also an algebraic expression because powers are in the form of rational numbers. Okay. Now the next thing is polynomial. Actually, polynomial is a special case of algebraic expression. What was in algebraic expression? The powers were in the form of rational, but here the powers are in the form of whole numbers. Okay, that is only the one difference between algebraic expression and a polynomial. Say like and polynomial, we are denoting polynomials with p of x. Say I am taking a polynomial like 3x square plus 5x plus 2 plus 3. Okay, here if you look, x has power 1, here x has power 0. So 2, 1 and 0, they are all the whole numbers. They are not in the form of they are not the rational numbers. They are also the rational numbers, but here we are discussing the whole numbers. They are all whole numbers. We call this is a polynomial. If I am taking like p of x is equal to 3x 2 power 3 and 5x power 1 plus 3x power 0. Here one difference between them is that x has power 2, here x has power 2 divided by 3. This is the polynomial, but this is not a polynomial because this is an algebraic expression. Algebraic expression has the powers in the form of rational numbers. Okay, you got the difference between polynomial and algebraic expression? Okay, thank you. Now the next thing is degree of the polynomial. Say I am taking an example, by that you can understand the degree of the polynomial. Say I am taking a polynomial p of x like 3x square plus 5x plus 3. Okay, degree of the polynomial is the highest power. You have to visualize all the powers, and after that you have to come out with the maximum power. Okay, say like here power 1 is 2, power 1 is 2, here power 2 is 1, and here I can take an x power 0. That means x power 0 is equal to 1. Here power 3 is equal to 0. But what I told you that degree of a polynomial is the maximum of all powers. You have to calculate, you have to find out the maximum of all powers. Say like you have to find maximum of P1, P2 and P3, which is equal to maximum of 2, 1, 0. Please, can you tell me that what is the maximum of this set? Clearly, this is 2. That implies I can say that the degree of a polynomial is 2. So, actually, this degree is nothing, just a maximum among all the powers. Okay? Now, on the basis of terms, on the basis of degree, you can differentiate polynomials. Actually, there are many types of polynomials, but on the basis of degree and also on the basis of term. I will first tell you on the basis of degree the types of polynomial. Okay. First one is linear. Linear. Linear polynomial is actually that has highest degree 1. Okay, say like I am taking the example p of x is equal to 3x, or I can take also an example like I can take 3 examples like 3x plus 4. Listen, x has highest power here 1. That implies the highest power has 1. Therefore, degree is also. Therefore, degree of this polynomial is 1. Here, if you see, I can make here x power 0 because x power 0 is equal to 1. That implies x has power 0, x has power here 1. The highest power is 1. Therefore, degree of this polynomial is also 1, same like this. Therefore, I can say that any polynomial that has the highest power equal to 1, then we call that polynomial belongs to that linear polynomial family. Okay. Now, second thing is quadratic polynomial. I will also take an example. Say like I am taking a polynomial p of x, which is equal to 3x square plus 4x plus 4. And next example, I am taking g of x is equal to 4x square plus 3. Listen, here the highest, here the power, I can also make here x power 0, also here x power 0. Listen, why I called this, this is a quadratic. Listen, x has power 0, here power is 1, here power is 2. So, powers are 0, 1 and 2. What is the maximum among all powers? That is 2. So, any polynomial that has the power highest to 2, we call that this polynomial is a quadratic. Or we can also say that this polynomial belongs to the quadratic polynomial family. Okay? And also, if the degree of a polynomial is 3, therefore, its leading quotient must be not equal to 0. Okay? Say like, highest, this polynomial has a degree 2. Because this is the highest. This is called the leading coefficient of this variable. It should never equal to 0. If it becomes 0, if it is 0, then we can't say that this is the 2 is the degree of the polynomial. It is always non-zero if you are saying 2 is the degree. Okay. Now the next now if you are taking a polynomial having degree 3, you call that a cubic polynomial, and if the polynomial has highest power 4 or you can say the degree 4, then this is a biquadratic polynomial. Okay. It was on the basis of degree. Now I will differentiate the polynomials on the basis of terms. Okay. First term is monomial term. Monomial term means the polynomial which has only one term. Okay, say like I am taking polynomial p of x which is equal to 3x, or I can take another example g of x which is equal to 3. This is also a term. Earlier I told you this is also a term, product of variable and constant. So monomial sorry, this is not monomial term, this is monomial polynomial. Okay, actually This polynomial has only one term. This polynomial has only one term. Those polynomials that have only one term, they are belonging to the polynomial family. Now, second is binomial family. Binomial polynomial. Binomial polynomial, bi means two. Where then what is called a binomial polynomial? A polynomial that has two terms. Okay. Say like I am taking example p of x is equal to 3x square plus 3. Here one term is this and next term is 3. Total terms are 2. So we call these types of polynomials as polynomial. Okay. Next, if there are 3 terms, then we call that trinomial. Similarly, like that. Okay. Now we have to discuss the zeros of the polynomial. Okay, zeros of the polynomial. Say I am taking an example, by that you will understand the zeros of the polynomial. Say I am taking the example p of x which is equal to x square minus 1. Also, if I am saying what is the degree of p of x, what is degree? Highest power. Here power is 0, here power is 2. Highest is 2, therefore degree is the degree of the polynomial is 2. But our thing is that zeros of the polynomial. We have to find zeros of the polynomial. Actually, zero of the polynomial is nothing but a value of variable that makes entire polynomial as a zero polynomial. Say like, if I am taking x is equal to 1, you have to replace the variable with some value. Okay, I am replacing x with 1. Now I will see p of 1 is equal to 1 square minus 1, which is equal to 1 minus 1 is equal to 0. After putting the value in a place of variable, the entire polynomial becomes zero polynomial. Such values we call them zeros of the polynomial. Okay. Say like I am taking example x is equal to 2. So in place of x we are putting 2. P of 2 is equal to 2 square minus 1, which is equal to 4 minus 1, which is equal to 3. This is also the value we are putting, but after putting the 2 in place of x, our value comes out to be 3. It does not come out to be 0. So we can't say that 2 is the 0 of the polynomial. Okay. Now if you are putting x is equal to minus 1, let us see what will be the value here. P of minus 1 is equal to minus 1 ka whole square, which is equal to, here you have to put the value minus 1 ka whole square minus 1. Minus 1 ka whole square is equal to 1, 1 minus 1, which is equal to 0. Okay. When we are putting minus 1 in place of variable, our polynomial becomes 0 polynomial. That we can say therefore 1 is also the 0 of this, minus 1 is also the 0 of that polynomial. And one thing you have to note down that if a polynomial has degree m, therefore number of zeros should not exceed the degree of the polynomial. Here degree was 2, therefore number of zeros are 2. It may be less than 2, but it should not decrease. It should not increase above that 2. It should remain within the 2. Okay. I will take a graph, and you will also learn how to visualize, how to find out the zero of the polynomial. Say I am taking a polynomial p of x which is equal to x. Okay. Say its graph looks like this. It is a straight line passing through the origin, first quadrant and third quadrant. This is my polynomial. This is the graph of this polynomial. See, this is the x-axis. This is the y-axis. Say this is the graph of this polynomial. This is cutting my x-axis. This is crossing my x-axis only at one point, that is at origin. This is the origin. Say I am taking as 0. This polynomial crosses my x-axis only at one point, that is 0. While it cuts, it becomes the 0 of the polynomial. Which point, at which point it cuts? At 0. So I will say also here that by visualizing the graph of a polynomial, I can also say that 0 is the 0 is the root, or we can say 0 is the 0 of the polynomial. Okay. Say I will take another example. See, listen. This is a graph of some polynomial, and this graph cuts x-axis at z1, say z2, z3, and z4. At 4 points, the graph cuts the x-axis. This is my x-axis. This is my y-axis. Okay, and the graph cuts the x-axis at 4 points. So I can say here, this graph cuts at 1 point, 2 point, 3rd point, 4 point. This graph cuts x-axis at 4 points. I can say that these points are the zeros of the polynomial, and the number of zeros is equal to 4. Okay. You can visualize also by that. While it cuts the x-axis, these points become the zeros of a polynomial. Okay. Thank you.